What if everything you thought you knew about weight loss, blood sugar, and appetite control was about to be turned completely upside down by a can of food that cost less than $1? Not a protein shake, not a detox tea, not a pill you order online at 3 in the morning. A plain, unassuming, sitting right there on the grocery shelf can of beans. I know what you're thinking. You've heard about Ozempic. You've seen the headlines, watched the celebrities, maybe even considered whether it might be right for you. And here I am telling you that the core biological mechanism behind one of the most expensive and talked about drugs on the planet is already available to you for 99 cents. I need you to stay with me until the very end of this video, because what I'm going to show you today is not a shortcut or a trick. It is deep, verified, published science, and it has the power to fundamentally change the way you eat, the way your body responds to food, and the way you feel every single day. My name is Dr. Watsun, and this is one of the most important conversations I have ever had with you. Let's begin with what Ozempic actually is, because I think most people have a surface-level understanding of the drug without grasping the underlying biology. And the biology is where the real story lives. Semaglutide, the compound marketed as Ozempic for diabetes and Wegovy for weight loss, works by mimicking a hormone your body naturally produces. That hormone is called GLP-1, which stands for glucagon-like peptide 1. You were born with the ability to make this hormone. Your gut makes it right now. The question is whether your gut is making enough of it and whether your lifestyle is supporting or suppressing its production. Because GLP-1 is not just a pharmaceutical concept. It is a fundamental biological signal that your body depends on to regulate blood sugar, control appetite, manage fat storage, and communicate between your gut and your brain. Ozempic is simply a synthetic, long-acting version of something your body already knows how to do. And when you understand that, an entirely new question opens up. What can you do naturally to stimulate more of your own GLP-1? What foods, what habits, what biological inputs cause your gut to produce this hormone in greater quantities? That question leads us directly and unavoidably to the bean aisle of your grocery store. GLP-1 is released by specialized cells in your intestinal lining called L cells. These cells are concentrated primarily in your small intestine and colon, and they are activated by specific components of the food you eat as it passes through your gut. When GLP-1 is released, it does several remarkable things simultaneously. It tells your pancreas to secrete insulin in a glucose-dependent way, meaning it promotes insulin release precisely when blood sugar is rising and stops promoting it when blood sugar is stable, a far more elegant and safe mechanism than older diabetes medications. It slows the rate at which your stomach empties its contents into your small intestine, which means food sits in your stomach longer. You feel fuller sooner, and you remain satisfied for hours after eating. It travels through your bloodstream to your brain, where it binds to receptors in the hypothalamus, the master regulator of appetite and energy balance, and sends a clear, powerful signal. You are fed, you are satisfied, you do not need more food right now. And it suppresses glucagon, the hormone that instructs your liver to release stored glucose into the bloodstream, thereby preventing the runaway blood sugar surges that drive insulin resistance and fat storage over time. Semaglutide achieves these effects because it is engineered to resist the enzyme that normally breaks down natural GLP-1 within minutes. Natural GLP-1 has a half-life of just 1 to 2 minutes. Semaglutide has a half-life of approximately 1 week. That extended duration is the pharmacological trick that makes it so effective and so expensive. But your body's L cells don't need a synthetic molecule to be stimulated. They respond to natural dietary inputs. And the most potent natural dietary input for L cell activation ever identified in nutritional science is the combination of resistant starch, soluble fiber, and plant protein found in legumes, beans, lentils, chickpeas, and their relatives. This is the mechanism. This is the connection. And it has been sitting in peer-reviewed literature for years, waiting for someone to explain it clearly enough that it could actually change people's lives. Let's talk about resistant starch first, because this is the most important concept in this entire video and the one most people have never heard explained properly. Starch is a carbohydrate, and most starches are digested in your small intestine, broken down into glucose and absorbed into your bloodstream. That process raises blood sugar. But resistant starch, found abundantly in beans, lentils, green bananas, and cooked and cooled potatoes and rice, resists digestion in the small intestine entirely. It travels through your small intestine untouched and arrives in your large intestine, your colon, intact. And in the colon, it meets your gut microbiome. Your gut bacteria feast on resistant starch through a process called fermentation. And during that fermentation, they produce a class of compounds called short-chain fatty acids, specifically butyrate, propionate, and acetate. These three molecules are among the most biologically active compounds produced anywhere in your digestive system. Butyrate is the primary fuel source for your colon cells, and it plays a critical role in maintaining the integrity of your gut lining. Propionate travels to your liver and helps regulate glucose production. And both propionate and butyrate directly stimulate your L cells to release GLP-1. This is not theoretical. This has been demonstrated in multiple controlled human trials. The fermentation of resistant starch in your colon is one of the most powerful natural triggers for GLP-1 secretion in existence, and every can of beans is loaded with it. The soluble fiber in beans adds another layer to this effect. Soluble fiber, which includes compounds like pectin, beta-glucan, and various gums found naturally in legumes, dissolves in water and forms a thick, viscous gel in your digestive tract. This gel physically slows the movement of food through your intestines. It coats the surface of your small intestine and reduces the rate at which glucose and other nutrients are absorbed into your bloodstream. The result is a dramatically blunted post-meal blood sugar spike, the kind of spike that, when repeated thousands of times over years of eating refined carbohydrates, drives insulin resistance, metabolic syndrome, type 2 diabetes, and progressive weight gain. Soluble fiber is also independently capable of stimulating GLP-1 release, meaning beans hit your L cells from two separate directions simultaneously, through resistant starch fermentation in the colon and through soluble fiber signaling in the small intestine. Then there is the protein content, and this is the piece that elevates beans from a good food to a metabolically extraordinary one. A single cup of cooked black beans contains approximately 15 grams of protein. A cup of lentils delivers around 18 grams. Plant protein is a potent stimulator of multiple satiety hormones, not just GLP-1, but also cholecystokinin, which is released by your small intestine in response to protein and fat and signals fullness to your brain, and peptide YY, another gut hormone that reduces appetite and slows gut motility. The simultaneous stimulation of GLP-1, cholecystokinin, and peptide YY after eating beans creates what metabolic researchers call a satiety hormone cascade, a coordinated multi-signal communication from your gut to your brain that says with remarkable clarity and persistence that you are done eating and you don't need more food for a long time. This is precisely what patients on Ozempic describe as the most life-changing aspect of the drug: the quieting of food noise, the disappearance of constant hunger, the ability to eat a reasonable amount and feel genuinely satisfied. Beans do this, not as dramatically or as instantly as a weekly injection, but consistently, cumulatively, and through pathways that strengthen over time rather than creating dependency. Now I want to share something with you that I consider one of the most fascinating discoveries in metabolic nutrition research, and it is called the second meal effect. When you eat beans for dinner tonight, your blood sugar response to your breakfast tomorrow morning will be measurably, significantly lower than it would have been without those beans. This phenomenon has been documented in clinical studies going back decades, and it was first formally described and named in research from the University of Toronto. The mechanism behind it is elegant, The resistant starch in beans continues to be fermented by your gut bacteria throughout the night, and the short-chain fatty acids produced during that overnight fermentation continue to stimulate GLP-1 secretion and modulate insulin sensitivity well into the following morning. The can of beans you ate for dinner is still improving your metabolic health when your alarm goes off the next day. There is one bacterial species I want to highlight specifically because it has become the subject of intense scientific attention: Akkermansia mucinifila. This bacterium lives in the mucus layer of your gut wall, and its abundance is strongly associated with metabolic health, leanness, and insulin sensitivity. People with high levels of Akkermansia tend to be leaner and have better blood sugar control. People with metabolic disease tend to have depleted Akkermansia, and research has shown that one of the most effective ways to increase Akkermansia in the gut is to feed it the fermentation products of legume fiber. Akkermansia thrives in an environment rich in resistant starch and short-chain fatty acids. Eating beans regularly creates exactly that environment. What makes this especially interesting is that some researchers now believe that part of semaglutide's metabolic benefit comes through its indirect effects on the gut microbiome, meaning that the drug and the bean are working, at least in part, through overlapping biological pathways. I want to spend a moment addressing the objections because I hear them all the time and I take them seriously. The most common one is bloating and gas. Yes, beans can cause gas, particularly for people who don't eat them regularly. This happens because the resistant starch and oligosaccharides in beans are fermented by gut bacteria, the same process that produces GLP-1 stimulating short-chain fatty acids. The gas is a byproduct of a beneficial process. For most people, the gas and bloating diminish significantly within 2 to 4 weeks of eating beans regularly, as the gut microbiome adapts and the populations of gas-producing bacteria stabilize. Rinsing canned beans under cold water for 30 seconds removes a significant portion of the oligosaccharides responsible for gas. Starting with smaller servings, a quarter cup per day, gradually increasing, makes the transition far more comfortable. The discomfort is not a warning sign. It is an adjustment period, and it passes. The carbohydrate concern is the next objection I hear most often, particularly from people following low-carbohydrate dietary approaches. And I understand the concern, but the glycemic data on beans completely undermines it. The glycemic index of black beans is approximately 30. Chickpeas are around 28. Lentils are as low as 21. Compare that to white bread at 75, white rice at 73, and most breakfast cereals above 70. The fiber and resistant starch in beans slow glucose absorption so dramatically that eating beans raises blood sugar far less than most foods commonly considered healthy. In study after study, replacing refined carbohydrates with legumes improves fasting glucose, reduces HbA1c, and decreases insulin resistance, even in people already diagnosed with type 2 diabetes. The carbohydrate in beans and the carbohydrate in white bread are not remotely the same thing metabolically, and treating them as equivalent is one of the most persistent and damaging misconceptions in modern nutrition. The anti-nutrient argument, centered on lectins and phytic acid, deserves a brief but firm response. Raw kidney beans contain high levels of lectins that can cause serious digestive distress. Cooked kidney beans do not, because heat denatures lectins completely. Canned beans are fully cooked. The lectin concern is entirely irrelevant to cooked or canned legumes. Phytic acid, which can bind to minerals like iron and zinc and reduce their absorption, is also significantly reduced by cooking, soaking, and fermentation. And emerging research suggests that the phytic acid remaining in cooked legumes may actually function as an antioxidant, with potential protective effects against colorectal cancer. The anti-nutrient narrative around legumes was built primarily on studies involving raw or improperly prepared beans, and has been repeatedly contradicted by large-scale epidemiological data showing that populations eating the most legumes have the best health outcomes across virtually every major disease category. Those populations deserve a moment of our attention, because they are the ultimate proof of concept. The blue zones, The regions of the world with the highest concentrations of people living past 90 and 100 in good health share very few dietary commonalities. Some eat fish, some don't. Some drink wine, some don't. Some consume dairy, some don't. But every single Blue Zone population, without exception, eats legumes every day. The Sardinians eat fava beans and chickpeas. The Okinawans eat soybeans and tofu. The Nicoyans eat black beans. The Icarians eat lentils. The Loma Linda Adventists eat a wide variety of legumes as a cornerstone of their diet. These are the longest-lived people on Earth, in the lowest income and highest income communities alike, across different cultures, climates, and culinary traditions. And they all eat beans daily. That convergence is not a coincidence. It is one of the strongest nutritional signals in all of human health research, and it points directly at legumes as a pillar of longevity and metabolic health. Track how you feel after 2 weeks of daily bean consumption. Notice your hunger levels between meals. Notice whether your cravings for sugar and refined carbohydrates begin to quiet. Notice your energy stability throughout the afternoon. Notice whether you feel satisfied on less food. These are the experiential signals that your GLP-1 system is becoming more active, your microbiome is shifting, and your metabolic machinery is beginning to work more efficiently. For those of you managing prediabetes, elevated fasting glucose, or insulin resistance, please track your numbers. The research suggests you will see measurable improvements within 60 to 90 days of consistent consumption, and those numbers will tell a story that is deeply motivating. Here is the closing thought I want to leave you with, and it is the most important one. The pharmaceutical industry has invested billions of dollars developing a synthetic molecule that mimics a hormone your body already produces naturally, and then charges you thousands of dollars a year to inject it. That is an extraordinary achievement of science, and for people who need it, Ozempic is a genuinely valuable medical intervention. But the conversation we rarely have loudly enough is this. The same biological pathway, activated through the same underlying mechanism, can be stimulated by food. Not perfectly, not as dramatically, not as immediately, but consistently, cumulatively, safely, and affordably by anyone anywhere who can afford a 99-cent can of beans. The gut was always the key. The L cells were always waiting. The microbiome was always shaping your metabolism. The science has known this for years. Now you know it too. If this video gave you something valuable, a new framework, a new understanding of your own biology, a new reason to look at that humble can on the shelf differently, then I want to ask you to do one thing. Subscribe to this channel right now and ring the notification bell so you never miss a video. Every week on this channel, I bring you science that is rigorous, research that is current, and explanations that are honest. The kind of in-depth health conversation that the healthcare system rarely has time for and the supplement industry has no interest in having. This community is built on one belief, that every person deserves to understand how their body works well enough to make real, informed decisions about their health. When you subscribe, you are joining thousands of people who have chosen to take that understanding seriously. You are investing in yourself, and it costs you absolutely nothing. Hit subscribe, turn on notifications. Share this video with someone whose health could change because of what they learn here today. I'm Dr. Watsun, and I'll see you in the next video, where the science is always on your side.